Okay, here we are continuing activity 1. So I put it into yet another video. It's just kind of a lengthy activity. So we're module 3, topic 1, lesson 3. This is the third part of activity 1. We're on page 376. So it says algebra tiles are helpful tools for combining like terms in algebraic expressions. However, because they only represent whole number tiles, you cannot use them to model all algebraic expressions. Number 7 says use properties to rewrite each algebraic expression. Ask yourself, did I distribute the factor to each term in parentheses? So we need to remember to do that. I'm going to zoom in. I'm going to do this left side here first, and then I'll move over and do the right-hand side. So they don't give us a ton of room to write here, so you're going to have to write kind of small or get a piece of notebook paper. So all of our terms here, I see 3 terms, the 2x, the 3x, and the 4 and 5/10 x. They're separated by the operations addition and subtraction, and they are all x terms, so I can combine those. So 2x plus 3x is 5x minus the 4 and 5/10 x, or 4.5x. So 5x minus 4.5 is 1/2, or 5/10 x. Final answer on that one. Okay, in letter C here, we have 5x plus 2y plus 1/3 x squared minus 3x. Okay, so we have 4 different terms, and it looks like there's only a couple that we can combine. So I have an x term here and an x term here. I can't do anything with the y or the 1/3 x squared. So, and most generally, might as well, I said this in a previous video, but I'll remind you now, we might as well get used to doing it. We generally write expressions with the highest power down to the lowest. So since this has a power of 2 on it, we're going to write that first. 1/3 x squared. Now let's put our x value. So we have 5x minus 3x, so that would give us 2x plus 2y. And that's all we can do there. We're done. Okay, letter E. Okay, so here we have the parentheses. And remember it said, did I distribute the factor to each term in parentheses? So that's what we need to do here. So if I distribute the 2 to the y and the 5, I get 2 times y, 2y, and 2 times 5 is 10. So remember we just did the algebra tiles, so it would have been 2 of the y plus 5. So we'd have a y and a 5, and then another y and a 5. So there's 2 sets of it, so we have 2 y's and 5 10. Okay, so that's just kind of our thinking there. It's not part of the answer. The same with the 2x plus 5. So this says x and a 5, and then another x and a 5 because there's 2 of them. So we have 2 x's and 10. These 2 expressions here are joined with an addition, this part of the expression and this part of the expression. So we have 2x plus 10. And again, this is just part of our thinking. So now the only thing that we have that's alike, we don't have anything to combine with the y's or the x's. So I'm going to rewrite 2x plus 2y. But then our constants are numbers, and they're called constants when they do not have a variable. We have 2 of those, so 10 plus 10 is 20. And there we are done with that one. Moving up here. So just like we can distribute a whole number of 2, we can distribute 2/3 times 6x. This is why they're saying that you can't use algebra tiles. So just like in this one, we're essentially doing 2 times y and 2 times 5. We're doing the same thing here. So we're doing 2/3 times 6x and 2/3 times 12. So I'm going to write it like that, 2/3 times 6x, and I'm just going to put it over a 1 plus 2/3 times 12, and I'm going to put that over a 1. Okay, so now 2 times 6 gives me 12x. 3 times 1 gives me 3. 2 times 12 gives me, so it's a plus sign, 24. 3 times 1 gives me 3. I can then simplify those. 12 divided by 3 gives me 4x. I have no idea where I'm going to write this. I guess up here, 4x, and 24 divided by 3 is 8. And you can't see that. There you go. Now you could have, for those of you who like to do the cross-canceling, you could have looked at the 3 and the 6 on the diagonal right here and said, I know 3 divides by 3 one time. 3 goes into 6 2 times, and then multiplied straight across 2 times 2, and we would have gotten right to the 4. And then on this one, 3 divided by 3 is 1, 12 divided by 3 is 4, and then when you multiply across, you'd have 2 times 4, which gives you the 8. Okay, I'm going to stick with the pen since we have a lot going on here. So I'm not doing anything with this 5. I'm going to rewrite it. 5 plus, so now I have 2 times the quantity of x plus 3. So that's 2 of the x's and 2 of the 3's. So that would be 2x plus, so 2 of the 3's gives me 6. So I'm multiplying here and here. And now it looks like these are my like terms. So I'll rewrite the 2x plus 5 plus 6 is 11. Okay, so 1/2 of 1/2 times the quantity of 4x plus 2 plus 8x. So 1/2 times 4x. So 1/2 times 4x over 1 plus 1/2 of 2 over 1 plus the 8x. Okay, so 1/2 of 4 gives us 2, so 2x, right? I can, if I multiplied it straight across, I'd get 4x over 2, which simplifies to 2x. If I multiply straight across here, I get 1 times 2 is 2, over 2 times 1 is 2, plus 8x. If I think about it here, what's half of 2? Well, half of 2 is 1, and 2 over 2 is 1, and then rewrite the 8x. Combining like terms, so we have 10x plus 1. And you couldn't see any of that. I am so awful. Okay, let's go over this again. I'm so sorry. So 1/2, let's just zoom out. I'm just going to rewrite it. My sincerest apologies. Okay, so we have 1/2 4x plus 2 plus 8x. So 1/2 times 4x. So we have 1/2 times 4x plus 1/2 times 2 plus the 8x. 4 times 1 is 4x. 2 times 1 is 2. Plus 1 times 2 is 2. 2 times 1 is 2 plus 8x. 4 divided by 2 is 2, so I have 2x, plus 2 divided by 2 is 1, plus 8x. Now combining like terms, I have 2x plus 8x, so I have 10x plus 1. All right, pause if you need to. I am just going to, I guess I'll just move on. Okay. Mr. Martin asked his class to write expressions equivalent to 7 times the quantity of 3a plus 5b and got 5 different responses for each. For each response, determine whether the student rewrote the original expression correctly. For those not written correctly, describe what describe the mistake the student made in rewriting the expression. So I'm just going to rewrite that down here. It's kind of too far away to see, really. 7 times quantity 3A plus 5B. So let's see, the first student got 10A plus 12B. So what should you get? If you distribute the 7 to the 3A, you should get 21. Oh, well, he must have done what? 7 plus 3. So his is a no. So he added 7 and 3, and then 7 and 5. So he added 7 instead of multiplying. Okay, 21A plus 5B. Well, we said 21A, so that part's correct. But then 7 times the 5B would be 35B, and he just rewrote the 5B, so no. So he distributed the 7 to the 3A only. He did not do it to the 5B. So then 7 times the quantity of 8AB. Oh, so he just added those together. 3A plus 5B. He has 8AB. You can't do that. They're not like terms. So his is a no. He combined unlike terms. Okay. 7 times the quantity of 3A plus 7 times the quantity of 5B. Well, that's right, because if I have 7 times 3A, I could write it like that. 7 times the quantity of 5B. Yes, so this is correct. Yes, correct. 7 times 3A, 21A. 7 times 5B, 35B. This one is correct. Sorry about the not seeing what I was writing there. My apologies, and I hope everyone is okay with that. Check in with me if you need to.